Hello mates, I am Kiran Jadhav here. In this session, I will demonstrate here a JVM architecture. See what is JVM? JVM it means Java Virtual Machine. Then itself available some memory. Then we'll come up with the architecture diagram here. See JVM architecture. First block we have available here class loader. Then there is available JVM memory like method area, heap, JVM language stack, PC registers, native method stack. Those are the 5 blocks available there. And again there is available execution engine itself available. JIT it means just in time compiler. And again it communicates with the native method interface and native method libraries. Now we'll start with one by one here. See class loader, it will help us to load the .class file. Then when .class file is created, once we are going to create the Java application, it means source code file. Extension it will be .java. Once this .java file is created, then by using Java compiler, it means Java C, it will convert .java into .class file. Then those .class file, it will be input for our JVM, and by using class loader, we are able to load those .classes here. And once .class file is loaded here, then accordingly our JVM we have available 5 block. Then it will split this data into particular memory area. Then first we have here available method area. Then in method area, whatever class level information, it always goes to method area. Class level information, it means like you can simply consider instance variable, static variable, methods, those always it will be class level. Then such a type of data goes inside method area. Now coming to next is heap. Whenever you are creating the object, then object always stored in heap area. JVM language stack, then whatever local whatever we are going to create like methods, and inside method suppose you are going to create some variables, those it will be like local variable, like such type of data it will goes to JVM language stack. Then next is PC registers. Under PC registers, whatever current execution instruction, it will goes inside PC register. I am giving the best example here for PC register, like sorry, if you are doing addition of two number, right, then you are using result equal to n1 plus n2, then this is current execution instruction, it will goes inside PC register. Next we have native method stack. Native it means you can simply say legacy, then whatever legacy method it will comes under native method stack only. Then coming to execution engine, see execution engine itself like Java interpreter available there, and just in time compiler also available there. What Java interpreter do internally, like whatever we have available bytecode, it means .class file, then it will help us like convert this bytecode into machine readable execution format of our application. It means bytecode we are not able to read. In short, .class file we are not able to read. Java itself interpreter available, and it will read the bytecode, and finally it will give us the output in machine readable format. Like this output we are able to see in Java console, and itself available in execution engine itself available JIT compiler, that's called just in time compiler. It will help us to improve the efficiency of our application. That's why Java application always give us the good performance, because itself available JIT just in time compiler, it will help us to improve the efficiency of our Java application. Now coming to next, we have native method interface and native method libraries. Those are the, you can simply say, legacy things. Then in this session I will cover up like what is JVM components like class loader, runtime data access, execution engine, then how JVM executes the Java bytecode, memory management like heap, stack, method area and garbage collection, and JIT compilation, and how the performance goes to optimize in Java application. For that perspective, we'll come up with some theory part here. See method area, those are the, you can simply consider like method area, heap memory, stack memory, program counter, that's called PC registers, right? Yeah. Then native method stack, those are the 5, you can simply say memory in JVM. Those are the 5 JVM memory available there. Then first is method area. Method area, this is, you can simply say like the method area stores class level information. Metadata it means data about data, you can simply say like class structure, there is field, methods, constructor, those always you can simply say comes under method area. In static variable also class level only, that also comes under our method area. Then whatever constant pool, string literals and constant, those also part of our method area itself actually, and method bytecode also. Then this area is shared across all the threads and it is a part of the heap memory. Then coming to next is heap memory. Heap memory, it means whenever you are going to create the object, it will goes to heap area, and the heap is used for dynamic memory allocation and stores. Like object and their instance variable always goes inside heap memory, and JIT-optimized code also goes inside heap memory only. And the important thing here, the garbage collector manages memory cleanup in the heap itself actually. Garbage collection, it's by default available in Java, like Java does not support to destructor. Then in Java we have available system.gc. System is a Java class coming from .lang package, and gc is a method itself available in system class. It will help us to clean up the object, you can simply consider. Like by referencing object as null and calling the system.gc, we are able to achieve the garbage collection in Java. It's also part of our heap area itself. Coming to next is static memory. Then here each thread has its own JVM stack which stores like method call frames, like for every method call you can simply say sorry. Next, local variable and method parameter. Whatever local variable you are going to create, it will goes inside stack memory only, and the partial results and return addresses also part of our static memory. In short, you can simply say whatever like local variable and those, it will goes inside stack memory. Inside method, whatever you are writing, it will goes inside stack memory only. Coming to next is program counter, PC register, you can simply say. Then whatever current execution instruction, it will goes to PC register. Now the best example I am saying, like result equal to n1 plus n2, then this will be current execution instruction, it will goes inside this PC register only. The PC register holds the address of the current instruction being executed in a thread, and each thread has its own PC registers since like JVM is multi-threaded. Then coming to next, this is native method stack. See here, this is native, it means you can simply say legacy. Like this stack is used for native, like non-Java methods, like written in languages like C or C++, and it stores like native method calls and native libraries and their execution details. Like this is like important, you can simply say 5 areas available within JVM itself actually, like method area, heap, JVM language stack, PC register, and native method stack. Then first method area, whatever class level information like variable, static variable, whatever instance variable, static variable, methods, it will goes to method area. Heap, it means whenever you are creating the object goes to heap area. Then JVM language stack, whatever local variables, it goes inside JVM language stack. PC registers, whatever current execution instruction, it will goes to PC registers. And native method stack, it means this is legacy methods, you can simply say, coming from C, C++. Then execution engine itself, like we have available Java as a Java interpreter, and it again there is available JIT as well, just in time compiler. It will help us to improve the efficiency of our Java application. Now coming to next is how the Java program compilation process happens internally. Then see, suppose we are creating here one hello world.java. Then .java, it means you can simply say this is the Java source code. Then we have available here Java C, it means Java compiler. It will convert this hello world.java into hello world.class file. Hello world.class file. The next, we have available execution engine itself available Java as a interpreter. Java itself Java interpreter here. And finally, it will read this bytecode. .class file, it means bytecode available there. Then Java itself interpreter, and this interpreter, it will read this .class file, it means bytecode, and finally it will give us the machine readable format as an output. And this output you will be able to see in Java console. Like this is the way like we are able to like compile and run the Java application. For demonstration, quick, I am just going ahead and creating the one application. I am using system level notepad actually. This notepad I am using here, and here I am creating the one hello world application. You can simply say here I am just creating the hello world application. See, you can say public, this will be class. I want to like maximize size of screen here. This will be hello world. Then here you can say we have, this is our main method, public static void main string type of array arguments we are passing here. Then here I am just adding printing statement like system.out.println, system.out.println, and here I am just trying to print welcome to full stack Java developer. See, I am just trying to print here welcome to full stack Java developer. Then see, this hello world, this is our class name, and here we have main method available, and inside that we are just using printing statement, and by using printing statement we are trying to print welcome to full stack Java developer. Now I am just trying to save this application. For saving this application I am just coming inside D drive, and there is already created the folder as Java, and inside that I am giving the application name as hello world.java. Then you will be able to see here we have Java folder and the class also available, and this is Java logo. It means you can simply say type is Java source file, the timestamp also latest timestamp only. And here if you want to run this application, right, then compilation process we are going to follow here. Like we have available hello world.java, then we are using Java C to compile our Java application. Then we'll simply come up with the here, and you can simply use cmd. And here nowadays we are using Java 17, it means I will use the first Java 11 feature. You can simply use Java and give the hello world.java. See, it will give us the output. Without creating the .class file also you are able to see the output. But if you want to create the .class file, then you can use Java C, give the hello world.java. See, within seconds .class file is created. See, this is the .class file, and .class file content we are not able to read it. Who is responsible? Java itself, Java interpreter. It will read .class file content, and finally it will give us the output in machine readable format. Then Java C, Java compiler, it will convert hello world.java into hello world.class. Now Java itself, Java interpreter, and it will read this bytecode, and finally it will give us the output in machine readable format. See, here is the output, like welcome to full stack Java developer. This is what we are expecting actually. Like such a way we are able to run the Java application by using command prompt. And you know, nowadays like we are using IntelliJ, Eclipse, STS as well, right, to use as a editor here. But if you want to check like how the compilation process happens, then you can simply follow such approach. Like first you can create the source code, it will be extension as .java. Then by using Java C, it means Java compiler, it will convert hello world.java into hello world.class file, and .class file it means there is available bytecode, and this one we are not able to read it. Who is responsible? We have Java itself, Java interpreter, it will read this .class file, it means bytecode, and finally it will give us the output in machine readable format, and this output you will be able to see in Java console as well. And here also we are able to see the output. Like such a way we handle here like this entire JVM architecture. But in short, coming at the last point, see, in JVM there is 5 memory, those are the very important for us. Then what is the purpose of those memory area? See, first one we have method area, like itself we are just going to store like class structure like metadata, static variable. Class structure, it means you can simply say like instance variable, class level methods, constructor, those will be stored under method area, including metadata and static variable as well. And this is shared across threads. Coming to heap, it means whenever you are creating the object, it will goes inside heap. Like object and instance variable, object you can simply say goes inside heap area itself, and this is shared across threads. Next, stack, it means you can simply select method execution a local variable, it will goes inside stack area. Each thread has its own stack. PC register, it means whatever current execution instruction, it will goes under PC registered, it means program counter, you can simply say register, and each thread has its own PC register. Next, native method stack, it means it like handles the native method execution, it means you can simply say legacy methods like coming from C, C++, and each thread has its own native method stack available there. Then we have available execution engine, itself Java interpreter available there, and internally they have available JIT compiler. It means just in time compiler. Again, JIT compiler, it will help us to improve the efficiency of our Java application. Like such a way we done with our JVM architecture. But till if you have any questions, then feel free to add your questions in comment box. And thanks for watching this video. Please do like, share and subscribe the channel to get more updates, and see you in next video.